that we see protocol is bounded with ZynetD to the port 69. This is the default port. We should just note that. Perhaps we'll list it here. Note, TFTPD listens to UDP 69 by default. So when you execute netstat mulp grep 69 to check if ZynetD is listening. This will tell you whether or not TFTPD is up and running and ready for service. Now from the router, we can attempt to copy the running configuration to the server's IP address of 192.168.75.199 as a given file name. That's going to be Linux CBT router 1.config. That's the file that it's going to attempt to write. From the full command, the router parses the IP address of the host from this block, and we need to confirm it. It also parses the file name. So we could have simply executed copy running config TFTP and then indicate the IP address and the file name after. Now after pressing enter, you'll see whether or not it's able to write to the remote server. It says the error code 0, received 20581, error opening this particular file, which will lead us to debug, of course. What we'll do is check the varlog messages file on the remote system. That's where ZynetD logs by default. And notice it reads that SE Linux is preventing user sbin.in.tftpd from being able to write to the file Linux CBT router 1.config. So the problem here is with SE Linux. So we need to adjust the SE Linux posture to permit writing by TFTPD. And again, this is a requirement for many of the services for certification that you configure the service to work within an SE Linux framework. Now, one other file we may look at to determine whether or not SE Linux is enforcing, although we can tell that it is because it won't allow us to write the file, is etc sysconfig SE Linux. This contains the policy for the system. Currently it's enforcing, and its type is targeted. So because it's enforcing, the security policy takes effect. However, if we were in dismissive, permissive, or disable mode, that is, we'd be able to write to the file without SE Linux's intervention. And the default Red Hat Enterprise implementation, which carries over from version 4, is the targeted policy, which targets specific network daemons, TFTPD included. So we need to again alter the configuration so that SE Linux is happy with TFTPD or doesn't get in its way. Now whenever SE Linux denies access, it logs in varlog messages information about that denial, which can help you to overwrite the denial. Let's tail varlog messages to take a look, and you'll see SE Linux is preventing it, and for more information we should execute SE alert followed by this unique code as it pertains to the message that impacts the TFTPD instance. So if we execute it, it provides us with useful information about the error. SE Linux is preventing, this is summary information, a given daemon, write access to the router config file. Here's a description, and here's how you go about allowing access. Now for this particular case, if you execute set SE boolean for TFTPD with the P option TFTPD disable trans equal 1 and then restart the TFTPD server, you'll then be able to write the file. Let's go ahead and give that a try. Once this is completed, we'll restart TFTPD. So execute the following: disables SE Linux for TFTPD. C restart using, of course, service ZynetD restart. This will cause TFTPD to be restarted as well. Now let's reconnect to the router. And then we'll execute copy running config to TFTP 75199 as Linux CBT router 1.config. Enter a couple times, and now it's written the file. So, with that said, from the local shell, let's take a look. There we have Linux CBT router 1.config. If we examine the contents of the file, we should be able to see it, and it should be fine. Also ensure that the file is writable by the world. So make sure, we should just note that change mod 666 the file name to permit TFTPD to write, unless you've overridden that feature using the -C option when you start TFTPD. If you man the in.tftpd man page, you'll see how you can override having to flag the file world writable. But you must flag it world writable in order for TFTPD, with the default startup, in order for TFTPD to work. So we've updated the file. It exists. We can examine the contents of it. And there we have it. We can change it from the router at any time. We can rewrite, in other words, and it will update the file. We may also use the TFTP client to pull the file using get. So an RPM query all grep TFTP will reveal whether or not it's installed, and it is. So we could, for example, TFTP and get it from the server. Again, when you execute TFTP, it throws you in interactive mode, but if you execute TFTP with help, you'll see that you can indicate the command to execute right off the command line. For example, let's just list as our fifth task, instead of the router, use TFTP client to download the router configuration file. To do so, we'll execute TFTP, the host IP address, followed by -C, and get the name of the file. This will download the file to the directory that we're currently in. Let's navigate to our home directory, and then execute by pasting the command. It doesn't look like much has occurred, but the exit status is 0. And now when we LSL Linux CBT router on, we see it. So we've pulled it just like that. And we can pull it from remote systems as well, providing that TFTP is installed. So let's find a window that's free in our local system. We'll log off the router. An RPM query all grep TFTP, which probably is not installed. Or maybe it is, we'll see momentarily. If it isn't, we'll use yum to install it. This will pull it down from the RPM repository, and once installed, we'll navigate to our home directory and execute what we just pasted earlier, which is to connect to the TFTP server and fetch the file. Now we've got the file. Now again, if you don't use TFTP with an option, it puts you into this interactive mode, which prompts you for the various settings. So now we're actually here. ls doesn't work, help does. You can get the file manually, and this will pull it manually in interactive mode. So we should note, is it option B, TFTP enters interactive mode. So note, TFTP client operates in both non-interactive, and interactive modes, depending on what you've indicated on the command line. So again, we've shown you how to back up your router's configuration, how to adjust the SE Linux policy for TFTPD so that the TFTPD daemon can write to the file, as well as how to pull that file from two distinct hosts. We pulled it from one, the Red Hat Enterprise 5 system, and two, from the VMware instance of that Red Hat Enterprise system, both running 5.x of the operating system. And now TFTPD is up and running. Now, to disable TFTP, since we're not using it currently, modify the etc zinetd TFTP file, either manually using nano or using the sed stream editor. And since we've got two lines, we'll just comment disable equals no and uncomment disable equals yes, then execute service zinetd restart, and then of course netstat nulp grep 69 to see whether or not it's listening. And these are sessions that will be killed momentarily. To be absolutely sure that they're dead, this is an opportunity to use the kill command to kill the process IDs that are listed. So for example, 24, 468, and 432. Now let's re-execute netstat, and those sessions have been killed. PSEF grep TFTP will reveal nothing's running. So this is working as expected. So we've disabled it, and when we need TFTPD in the future, we'll enable it, but we have both client and server installed and ready for usage.